looking at 6.3, the operations of functions and their domain. When you are adding and subtracting, you can do this if the base variables and the powers match. So what you're doing again is looking for like terms, but the variable and the power must match. Here's a simple example. If f of x equals 5x to the 1/3 and g of x is equal to negative 11x to the 1/3, find f plus g. What's the answer of f of x plus g of x? Well, since x to the 1/3 and x to the 1/3 match, this is a doable question. 5x to the 1/3 plus negative 11x to the 1/3. Like terms, all you're looking for is the numbers in the fronts. 5 subtract 11, negative 6x to the 1/3. Find f of x minus g of x. Be very careful when you do your notation. 5x to the 1/3 minus negative 11x to the 1/3. Minus, minus, change, change. 16x to the 1/3. Do not change the base and do not change the power. That stays the same when you're doing like terms. When you're multiplying and dividing functions, you have to remember your exponent rules. If you had a to the n times a to the m, remember that you add your powers, a raised to the n plus m. If it's division, a to the n over a to the m, this time you subtract, a raised to the n minus m. If the function f of x equals 8x and g of x is equal to 2x to the 5/6, let's find f times g, and then we'll find f divided by g. F times g, 8x times 2x to the 5/6. If you need to rewrite this to put like things next to each other, perfectly fine. 8 times 2, x to the first times x to the 5/6. 16, x to the 1 plus 5/6. You need to make sure you have common denominators. Remember that 1 would be the same thing as x to the 6/6 plus 5/6. 16, x to the 11/6. You don't need to reduce that fraction. Leave it as raised to the 11/6. F divided by g, 8x over 2x to the 5/6. Again, remember you've got x to the first. 8 over 2 will give you 4, and then x raised to the 1 minus 5/6. 4x to the 6/6 minus 5/6. 4x to the 1/6. All right, so now we have to talk about this domain stuff. Remember, domain is referring to any x number that works in the function and also x's that must be excluded. We're going to be looking at fractional powers, so we do have exclusions on things that do not work in your x number. And here's the other thing we want to remember. Anytime you're dealing with the fraction f of x divided by g of x, you cannot have 0 in the bottom. You're dividing by undefined. That doesn't work. So how do you decide where you're going to look? Where I want you to concentrate is looking in the power. Whatever the x is raised to, x raised to the 1/3 power, x raised to the 1/4 power. Look at the power. Do not look at the constant in the front. You need to look at the power and you need to decide, is that fractional power even or odd? And where do you look for that? The denominator of the particular fraction. Here's case number 1. If the denominator of your fraction is odd, like this one, 27 raised to the 1/3, then we have no restrictions on x. I could put in any number I want and I will get an answer. So here's a sample for that. Can I put in 27, a positive number, 27, and do 27 to the 1/3? Sure, that's doable. My answer is 3. Can I put in a negative number and do negative 27 to the 1/3? Yes, that's also doable. That answer would be negative 3. And can I put in 0? Can I do 0 raised to the 1/3? Well, 0 raised to anything is still 0. So positive numbers work, like positive 27. Negative numbers work, like negative 27. And 0 works. So that shows that there are no restrictions on what I put in as my base number when I raise it to an odd power. So every odd power has a domain that's called all real numbers. If your denominator is even, that means the number you're looking at, the x value that they're looking at, must be non-negative. It can be 0, it can be positive, but it cannot be negative. So for instance, if I take an x number like 16 and do 16 raised to the 1/4, 1/4 being my even number, look in the fraction denominator, 16 to the 1/4, that's doable. My answer is 2. But if I try to do negative 16 to the 1/4, that would look like this. Negative 16, the 4th root of. I can't find a number that multiplies together 4 times and gives me a negative 16. There'd be an I value involved there, and I values are not real numbers. So that restricts the domain that I can put in for my value of x. I cannot put negative numbers in. It doesn't work. I can put in a positive value. I can put in 0. 0 again raised to an even power like 1/4 is doable. I get a 0. So the only number that will not work when I raise it to an even power is negatives. So my domain for even powered powers must be non-negative. So here's kind of a little chart that you could write down that might help you remember this. When you're looking at choices for the domain, we've got 3 basic choices. It's either a negative value, or could we put in 0, or could we put in a positive value. So let's look at this one with odd. If you have an odd number, I could do any x number raised to an odd power, like 27 we looked at, 27 to the 1/3. That would work, yes. I could do 0 raised to the 1/3. That would work, yes. I could do negative 27 raised to the 1/3. I get negative 3, so yes, negative numbers work. So for any odd power, I could put in anything I want for my domain. That's called all real numbers. A lot of times we'll use this symbol, capital R with 2 bars, all real numbers. If I have an even power, now I have some restrictions. I could put in a positive number, like 16, the square root of 16. That works. A number raised to an even power, 16 to the 1/2, that's okay. 0, 0 raised to the 1/2. Can I do a 0 to an even power? Sure. But can I do negative numbers to an even power? Can I do the square root of negative 4? No, I get an I value. So negative numbers are out. I can't do that. And the domain we used for that is called non-negative. And then here's the other one you need to remember. If you are dividing 2 functions, right away you must recognize that the function in the bottom does not exist if it is 0. So 0 is always out. 0 is excluded as a value in that particular function. And we just refer to that as not 0, can't have 0. Sometimes we say the phrase all reals that are not 0, all reals excluding 0. So let's go back and look at the first example that we did. We had f of x equals 5x to the 1/3, g of x is negative 11x to the 1/3. The f function is odd. That's this power right here, 1/3 power. That means my domain is anything. I could put in a negative value for x, I could put in a positive value, I can put in 0, and it's all doable. So the f function has a domain of all real numbers. My g function is also an odd power, which means it is also all real numbers. So if I'm asked to do the function f plus g, and I'm dealing with real numbers and another real numbers, there's nothing that's restrictive at all, which means my answer is then all reals. The same thing will hold with f minus g. Since it's reals with another reals, and all I'm doing is subtracting, that domain is also all reals. When you have 2 functions being put together, you always look at the most restrictive of your 2 functions. That will help you decide what the overall answer domain will be. In the second example we did, we had the f function as 8x, and the g function is 2x to the 5/6. Now remember, we're looking at powers. So this 8x raised to the first, that's like 1 over 1. I could put in anything I want as an odd value, and that will work. So my f function, being an odd value, all reals. My g function, however, is x raised to the 5/6. That's an even number, and even numbers are restrictive. I cannot have negative values. So when I look at doing f times g, my f function was all reals, but my g function said I can't use negatives, which means the only domains that are left are 0 or positive. That's called non-negative. When I do the f divided by g function, remember your f function we said was all reals, and the g function we said was non-negative. So if we look at our three choices of negatives, 0, or positives, my f function had no restrictions. My g function said I can't use negatives, so I cross off the negative choice. And then I'm asked to do a division question. I'm not allowed to have 0 in the bottom of a fraction, so 0 is out as a domain as well, and the only domain values that are now left standing are positives. So the domain of this would be positives only. All right, let's look at this next example. Negative 2x to the 2/3, g function 7x to the 2/3. Let's find f plus g and then list the domain. Negative 2x to the 2/3 plus 7x to the 2/3. I've got the same variable, same base. This is a doable adding question. Negative 2 plus 7 is 5x to the 2/3. Now let's talk domain. The f function is an odd power. Odd powers have no restrictions, all real numbers. Your g function is also an odd power. Odd powers have no restrictions. That's also all reals. So the domain for the whole question, all real numbers. I was born in the city of Landstuhl, Germany. Landstuhl, Germany. Find f minus g, your f function. Negative 2x to the 2/3, subtract 7x to the 2/3. Negative 2 minus 7, negative 9x to the 2/3. That's the value of the function. And then the domain. Again, odd power, f function is all reals. G function, odd power, all reals. Neither of those is restrictive, which means my overall domain, all real numbers. I think there's one more here, yes. Let f of x equals 3x and g of x is x to the 1/5. Find f times g. 3x times x to the 1/5. 3 times 1. The product property, I have to add 1 plus 1/5. Let's change this guy, 5/5. 5/5 plus 1/5, 6/5. There's the answer to the function multiplication. Now we do the domain. Your f function, 1 over 1, that's an odd power, all reals. Your g function, x to the 1/5, that again is odd, all reals. I have no restrictions between that, so my domain is all reals. The divide question, 3x divided by x to the 1/5. Let's put in 5/5 and do our division. 3 over 1 still stays 3. X to the 5/5 minus 1/5 is 4/5. There's the answer to the divide question, and then the domain. Your f function is odd, all reals. Your g function is also odd, all reals. But remember, we've got a divide question, so I cannot have 0. When I look at my three options, can't have 0 in the bottom. Everything else works, and remember the way that you can say that is all reals as long as you exclude x is not 0. So you can say it just like that, all reals, not 0. All right, I believe that is it. Yes, that is it for your function, addition, subtraction, multiplication, division, and dealing with domain. Go ahead, go to Skyward, and look for the online quiz for 6.3, Day 1, 6.3, first part.